In continuing our review of Chapter 6, I'm going to lump together sections 6.2, 3, and 4. They all deal with different types of factoring. Section 6.2 talks about factoring trinomials with a leading coefficient of 1. So that's problems that look like x squared plus bx plus c. They don't have a number in front of that leading term. The steps you would follow, step 1 is to always check for a GCF, may or may not have one. Step 2 is to find two numbers that multiply up to whatever number is in the position of C and add up to the number in position B. Let's call those M and N. Then our answer is going to be x plus M times x plus N. Occasionally, the M and N that you would need don't exist, in which case your problem is called prime. If we are factoring trinomials that do have a number in front of the x squared, there's a couple of different commonly taught methods. One method is called the AC method because, well, after you check for any GCF, then you look for two numbers that multiply not just to C, but to whatever A times C is. And those same two numbers will add up to B. So again, we'll call those numbers M and N. The third step would be to replace the BX with M and N, putting the variable on them, thus making a four-term polynomial to factor by grouping. The other option is trial and error. And as its name implies, basically you're just trying different possibilities until you get the right answer. So I know that it's a binomial times a binomial. And I know my answer is ax squared plus bx plus c. What I also know is that when I multiply the first two numbers, I get ax squared, and when I multiply the last two numbers, I get c. And so that's kind of giving me my choices for trial and error, and we'll do some examples here in just a minute. The difference of two squares is a pattern that you use when you have a binomial. It's the two part. It's subtracted. That's the difference part. And both terms are perfect squares. When you have that, a squared minus b squared, the pattern is a plus b times a minus b, where the a and the b are the square roots of your original problem's values. Then we have the sum or difference of cubes pattern, is another binomial. This time it can be add or subtract, and both terms are perfect cubes. When we have the cubes pattern, it's slightly different if it's adding versus subtracting. How it works is the first parenthesis, the sign is the same as the original problem. And we're filling in with cube roots, the cube root of A and the cube root for B. And then the opposite sign, and always positive. and just utilizing the A and the B that we found and doing some more manipulation with those values to fill in the second parentheses. So our directions for our examples are just going to say factor, and we have to determine which type of factoring we're using. And this first problem is a trinomial, no number in front. So I'm looking for two numbers that multiply to negative 30 and add to negative 1, which is going to be negative 6 and 5. The y on the end just means that when I write my answer, I need a y on the second term. Part B is a trinomial. We have a GCF first. There's an n on all of them, plus 3 can divide into all of them. And then we have a trinomial with no number in front, so I'm looking for two numbers that multiply to 40 negative and add to negative 3, which is going to be negative 8 and positive 5. Part C, we have a trinomial with a number in front. The AC method would look like this. I would look for two numbers that multiply to 6 and add to 7. 6 is from 2 times 3, so that's 6 and 1. So I replace that middle with 6x and 1x, and then I factor by grouping. I get x plus 3 times 2x plus 1. If I were doing trial and error, I would start out with two blank parentheses, and I would think, okay, what multiplies to 2x squared? And my answer would be x times 2x. And I'd say, okay, what multiplies to 3? And my answer would be 3 times 1. And I'd try foiling this back out, and I'd find it works. If I, let's say I flip-flopped the 3 and the 1, it would not work. So that's why it's trial and error. You try the different combinations until you get one that works. Part D is a squares pattern. The square root of 9a squared is 3a. The square root of 16b squared is 4b. So we have 3a plus 4b and 3a minus 4b. Letter E is another squares pattern. We have 4a squared plus 5 times 4a squared minus 5. Parts F and G are cubes pattern. The cube root of x cubed is just x. The cube root of 27 is 3. So we have x minus 3, x squared plus 3x plus 9. I got those values because this would be like the A and this would be the B. So we have A minus B, and then we square it, we multiply them together, and we square the last part. Part G, cubes pattern again. So we have the cube root of 27a to the 6th is 3a squared. And the cube root of b cubed is b. So I have 3a squared plus b. And then what I'm going to do is I'm going to take 3a squared and square it. So it's going to be 9a to the 4th minus. Then I'm going to take 3a squared and multiply it with b. Always positive, b squared. So that was a quick review of the different types of factoring.